is 135, the task is 200, the distance from A to B is 600, wind velocity is 080 at 35. Calculate distance and time to CP. So very simple, straightforward sum. So we are flying from A to B for a total distance of 600 nautical miles. Okay, let's draw the table from to back, dash, wind velocity, and ground speed. Ground speed outbound from A to CP. So let's say our CP is here. Ground speed outbound from CP to B and ground speed homebound from CP to A. So like always we have done this. So now ground speed outbound from A to CP. A to CP. What will be the track from A to CP outbound track is 135. So 135. The task that is given to you is 200. Wind velocity is 080 at 35. We have to find ground speed. So let's calculate ground speed. So ground speed is how much? So task in this question is 135. So correction 200. True course is how much? True course is 135. Wind speed is wind speed is 35 knots and direction is 080. So ground speed will be 177.86. 177.86. Let's verify. Task is 200. Track is 135. Speed is 35 and direction is 80 knots. Okay, so with that, our speed is 177.8 or approximately 178 knots. Now we are going from CP to B. So track will be the same 135. Task is the same. They have not given reduced task. The only one task that they have given, we have to use it. 080 at 35. So speed will again be the same. Now we are coming back from CP to A. So homebound track will be opposite of 135 or reciprocal of 135, which is 135 plus 180, 315. Reciprocal of 135 is 315. True airspeed task, wind velocity 080 at 35. So your ground speed is how much? Let's use calculator. True airspeed 200, true course 315, speed 200. So your ground speed is 218 knots. That's 200. Okay. At 315 because it's a reciprocal track. Speed 35 and direction 080. So ground speed is 218 knots. With this table complete, now let's use the formula. Critical point is equal to dho plus h. So total distance is 600. Homebound speed is 218. So 218 plus 178. Outbound speed is CP to B outbound speed 178. So now you multiply that. After multiplying, you will get 600 into 218, 130,800, 130 at 800. 218 plus 178 equals to 396. So critical point distance is 130,800 divided by 396. 330 nautical miles. 330 nautical miles. Time to CP will be equal to distance to CP divided by ground speed outbound from A to CP. So distance to CP is 330 and ground speed A to CP is 178. 330 divided by 178 is 1 hour 51 minutes. 1 hour 51 minutes. So time to CP is 1 hour 51 minutes. So 330 nautical miles and 1 hour 51 minutes. So select the option which is closest to both of them. So let's go to question number 47. So again a quick recap. Simple data was given to us. With that data draw the table, put appropriate values and substitute the values in the formula. Say you get your full marks in the paper. Question 47. If distance to CP in case of engine failure is 389, so distance to CP is 389. Okay, track is given, wind velocity is given, task normal. Okay, that is the true airspeed before engine failure is 250. True airspeed after engine failure is reduced task which is 200 knots. You have to calculate time to CP and you have to calculate leg distance. What is leg distance? The total distance from A to B, this distance. Okay, so let's go step by step. We have point A, we have point B. So this total distance is D. So now you have to calculate this total distance D. Okay, so we will find that out. Before that, let's draw the table from to act as wind and ground speed. I use this from to track task winds and your ground speed. So ground speed outbound from A to CP, ground speed outbound from CP to B, and ground speed homebound from CP to A. What is your track when you go from A to CP? Track A to CP is 40, 040. What is task given to you? Now there is a condition of engine failure. So let's understand this. We have done this. I will explain this again. From A to CP, your aeroplane is working fine. All your engines are working. So you will have task at normal. Okay, so normal engine working. So true airspeed will be based on all engine working. At critical point, you suffer engine failure. So once your engine fails at critical point and you make a decision to continue to destination or come back to airport, the time taken will be the same. But since your engines have failed, now the speed of aircraft will decrease. So you will have, if you continue to go towards Bravo. You will fly now at TAS R, which is reduced TAS speed. If you continue or if you decide to come back to point A, your departure airport, you will fly at TAS reduced. So before engine failure, you will be flying at normal TAS. After engine failure, you will be flying at reduced TAS. So now when you go from A to CP, you have not yet faced an engine failure. So you will be flying at normal TAS, which is 250 knots, which is 250 knots. Wind velocity is how much? The same, 230 at 40 knots. 230 at 40 knots. What is ground speed? So let's put this in the CX3. Track is 040. Your task is 250 and wind speed is 40, 230 at 40. So your ground speed will be 289 decimal 3. Your ground speed will be 289 decimal 3 knots. So 250 task, course 040, 230 at 40 knots of wind speed. So ground speed is 289. So ground speed is 289. Now when you go from CP to B, you will be flying at reduced task. Okay, reduced task. So now the true airspeed that you will use is this, 200. Wind velocity same, 230 at 40. So now ground speed will be, task will be 200. Course is 40, speed is 40, and direction, wind direction 230. So currently your ground speed will be 239 decimal 2. So 239 knots. 239 knots. Now when you come back from CP to A, you will be flying a direction which is reciprocal of 040. So reciprocal of 040 is 180 plus 40, 220. And you will be flying at a reduced task. That means you will be flying at a speed of 200 knots. Winds will be 230 at 40, and ground speed will be 220, task 2200, speed 40, direction 230. So your ground speed will be 160 decimal 49er. So 160 knots. So 160. So now our table is complete. So far we have been given DCP equals to 389 nautical miles, distance to critical point. So always we find it, now they have given to us DHO plus H. So we don't know the value of D, that we have to find out. So let that be like that. H is 160. O is outbound, CP to B is 239er plus 160 again. So 160 into D divided by 239 plus 160 is 399. Therefore cross multiply 389 into 399 divided by 160 equals to your D. Therefore D equals to 389 into 399 equals to the value 155211 divided by 160, 970 970 nautical miles. Okay, 970 nautical miles. So from total distance from A to B equals to 970 nautical miles. 970 nautical miles. Next thing they have asked us to find time to CP. So time to CP will be distance to CP divided by ground speed outbound A to CP. So distance to CP nautical miles. Time to CP will be equal to distance to CP divided by ground speed outbound A to CP. Distance to CP is 389 divided by ground speed outbound A to CP is 289. So time to CP will be 389 divided by 289. 1 hour 20 minutes. 1 hour 20 minutes. 1 hour 20 minutes is your critical point time. So let's go to next question. The only thing that you have to remember in this question is the use of reduced task. Okay, otherwise everything else is same. Nothing has changed.